A few days ago, this paper was shared in the Dental Biomaterials and Science Research Group on Facebook and led to this following statement by Dr. Salvatore Sato. He talks about the most important problem related to dental fillings in demineralized dental tissue is the lack of therapeutic bioremineralization, which can extend the durability and the resin-dentin bonding interface created by our dental adhesives and composite resins. Glass ionomer cements, although along with most of our current restorative materials in minimally invasive dentistry, do not induce nucleation of new hydroxyapatite crystals. That is very critical, folks. This is very exciting, and this is the kind of stuff that I'm learning and that you can too on this website and on this Facebook page. It's the first collaboration of scientists and dentists from all over the world to learn from each other. So we need biomineralization, which led me to this discovery. When the clinical applications, and when I first was introduced to ACTIVA over 4 years ago, it intrigued me, and it made me very, very interested in determining and finding out what's really going on with this material. And I wanted to see if it could bridge the gap that I've been looking for and that I've described to you. And I think that this material is a forerunner of so many great things that we go for in the future. The science presented to me at the time when I first looked at this was very exciting, based on, you can tell, my excitement of the procedures that we're doing as the talk of this evening. And as I work with this material, I learn more and more about what it can do. So let's look at some of the information and the data on it. First, this material itself does not create a hybrid layer, as we have been used to in our conventional materials. It creates an ionic interface with the tooth structure, not unlike what we were seeing that's initially formed with the glass ionomer materials, which, of course, glass ionomer is my first material love. However, unlike glass ionomers, this material will release calcium and phosphates, which form, as we've seen from Jeffrey's work, the important for apatite formation. And importantly here, I want you to note that when you're using this material, it's able to be used either via light curing or self-curing or dual curing. It's a remarkable material. So when you're applying it to the tooth surface, allow the material to remain in contact about 20 seconds before you cure in the light curing stage. That will enhance the overall bond to the dentin and allow the resin to get more intimately in contact with the dentin itself. I recommend that you do that. Personally, I'm currently using a belt and suspenders kind of an approach. I'm using bonding agents and then using the ACTIVA, and I'm still letting it sit 20 seconds before I cure it. But interestingly enough, as we've determined, the bonding agent enzymatically is going to be broken down. The really great part is that as ACTIVA gets to work further and further, it is able to penetrate through the adhesive and actually start the remineralization process and adhesion process via the apatite formation of the calcium and phosphates that are embedded and ingrained and part of the living mechanism of ACTIVA. It is a really remarkable product. It's also interesting in that it has this rubberized urethane component, which provides toughness and durability to the material. It's able to absorb and dissipate chewing forces and will resist fracture. I have not encountered sensitivity in all of the restorations that I have placed with this material. This study talks about the compressive strength of the material compared to other popular brands, and it is very, very strong. This next review shows the wear factor, and ACTIVA wears equally well as this Tetric and Filtex Supreme. And also deflection and breakage. We can see here that it is able, and it's very, very tough, it's able to absorb the stresses and resist fractures better than many other materials.